Okay, so we want to, like I say, we want to download this traffic underscore functions.zip file and unzip it into a directory. So you need to make a directory where you're going to put this, and you need to make sure that both those functions are in that directory. Now, these functions are just, they're a script file, but you can create any function you want. It's really easy. All you have to do is just create an M file, and at the top of the M file, you put in the word function, and then you have some value that it's going to return, all right? And then the name of the function. Now notice that the name of the function and the name of the M file match. Okay, so you want those to match. And then here are the values that we are going to pass into this function. Okay, so we're going to pass this value in there. And then, of course, these are comments. But what's cool about a function is all these comments right here below the function line. When you run help, if you come over here and at your command window and use the help, it will actually display those comments. Okay, so when you build a function, you want to make sure that you put information here about what this thing's all about. So you describe what the input arguments are all about, what the return value is, and any information you want to put in there. And then when you run the help, it'll actually display that. Okay, so it's and then you just do whatever you want to do. Okay, so now this one here. Okay, so let me see where this plot is. I have this plot in here somewhere. Up at the very top is the plot. All right, so so this is the plot, or this, this was basically like a Google map, and then I threw these stop signs on here, showing you that what we want to do is we are at the mall, and we're going to drive up 77. All right, so the idea here is that we are right down here at the bottom. Let me see. All right, so the idea here is we are over here at the mall. All right, so we're right down here at the mall. That's where we're at. And so what we're going to do is we're going to drive up, we're going to go at this light, okay? And then we're going to come down here underneath the highway and get on this on-ramp and go up to Portage. Okay? And so then we're gonna drive up to Portage and get off at Portage and come over this way. Let's see, where are we going? Sorry. Under the bridge, 1 mile to Frank. Yeah, so we're going to So we're going to come over here to Frank, and then we're going to come down Frank to Mega. And, you know, when we're going to be at the college there, at the K building, I guess. All right, so that's what we're doing. We're going to try to model how long is this going to take, and is this, and actually the whole homework. So when you go down below, the what we're going to do is we're going to go up Dressler and University Drive. So what we're going to do is we're going to say, okay, well, in the later problems, we're going to go up this way over University Drive and come over here. And the question is, which is faster? Okay, so I mean, that's kind of what the overall homework is all about. Okay, so we're going to go both ways from the mall to to Frank. One way we're going to jump on a highway over here, and you know, we can theoretically at least drive 65 mile an hour on a highway, but it's a lot longer, and there's actually, looks like, quite a few more stoplights up here that we're going to have to go through. So the question is, which is the best way? And so we want to model this so we can kind of come up with an estimation of what the best way will be. Okay, so we're going to start off then. If you look at the first problem over here, then I assume we've already turned on to, what is that, Whipple there? Or that's not Whipple. Everhard, is that Everhard? I forget. Whatever that road is. So, but I assume we've already turned on to this road over here. Okay, so, and and so the idea then is what we're going to have to do is we're going to have to turn on to 77 right here at this intersection. Okay, and so there's a 50% chance. There's a 50% chance here that it's going to take, we're going to have to wait 10 seconds. Okay, so how do you think we can do that? I'll give you a hint. It has nothing to do with the two functions I've given you yet. I want to predict that it's going to take me 10 seconds to make this left right here.
So would that just be you do an if and then statement?
Yeah. Okay. That sounds like a good start. All right. So let me start a new okay, I always like to put more than just like problem 1 on here, so I'm going to say this is like route 77 traffic. I like to give it a bigger name. All right, so all right, so this is just going to be our regular script here. So let me just get it started. I'm going to put in the okay, so we're just going to have our clear, and I guess eventually I'll have a figure, so I'm just going to do that and clear that figure. And I don't know, my OCD's getting me here, so I'm going to put capital letters up here. But You know, just your initial setup. All right. So now the first thing we want to do, I'm just gonna make a note of this. Okay. So here we're gonna turn on to the on ramp of 77 by making a left turn. And there's going to be a 50% chance we may have to wait 10 seconds for the for cross traffic. All right. So if statement. If what else, and of course our end if. All right, so you've given me an if statement. That's a good choice. Okay. But what if what?
If we have to wait, add
Okay,
10
so how do we determine that?
If left, like left underscore turn is less than, would you do like a less than 50?
Almost. Remember that the random function gives you a number between 0 and 1. So you need to
Yep.
actually do a 0.5. So what you want to do is you're going to run the random function and say if the random value is less than 0.5, then traffic time. Now, what the one thing I haven't done is, that I'd like to do, I guess, is initialize total time. So the total time for travel, right? We're going to start that to be a 0. Okay. And so the total time is 0. And then we're going to run this. Okay. And so if the total time is 0, but now we're saying that if this is less than that, then that's my 50% chance, then the total time is equal to the total time plus 10. Add 10 seconds.
Okay.
Otherwise, I guess we could kind of do it. Otherwise, I guess we don't need an else. Okay, so we don't really need the else here because otherwise we made the left turn and we're good. We don't have to wait.
Okay. But if you switch those and say, if random is less than 0, total time equals total time, and then you would need an else statement.
Well, if I gave you another case where the if I gave you like an extra case, let's say that I gave you have a 50% chance of waiting 10 seconds, and you've got a 20% chance of waiting 60 seconds. Let's say the traffic's really bad. You know, this time of year, with the holidays coming up, it may not be quite so bad this year, but in general, I don't know if you drive around the mall much during November and December. Just this whole Belton Village area, traffic can really be a bit of a nightmare, especially like on a Saturday evening, right before, a week or two before Christmas or stuff like that, or on Black Friday.
Mm-hmm.
So, you know, so if I gave you this other chance, this leaves waiting 60 seconds, right? So this leaves the chance, this leaves a 30% chance you turn right now, turn right away. Okay. Now, one of you have the volume up really loud and it's feeding back to me. If you could turn your
It might be
volume down
me.
just a notch. Okay, so the sounds better. I don't hear myself anymore. Thank you. Okay, so the so if we had this case, then what I would actually do is I would have to save this random value. So I would have to like save call it turn or something, I guess. Turn chance, call it something like chance to turn. And then I would run the random function. And now I would be comparing the chance to turn. Okay, so the chance to turn is less than half. That's a 10-second wait. And then I would do else. Then I would do an else. Actually, I guess I'd do an else if. Okay, so I would do an else if chance to turn is less than 0.7, then the total time would be 60 more. All right. And then, I mean, you could do the else. I mean, this is kind of redundant. This doesn't make sense. If I put in an else here and said total time is equal to total time, that's not really doing anything. Okay, so, you know, there's no point in that. Okay, but you see the use of the else if here. Do you notice why I did 0.7? Because I've already did 50% here. So we had a 50% and then we had another 20%. And so that, you know, we've already checked for 50%. So at this point, I'm checking to see whether there's 20% more. You see how that works?
Yeah.
Mm-hmm.
All right. So, all right. So we'll remove that then. But another way I could have done this with the else, see, here I was initializing my total time, but in this particular case, which I may not always be able to do that, but I could just initialize it this way. All right, because I don't have to add anything, but I do have to make sure the total time gets set to 0. All right, and so I could do that there. So now, anyhow, so now we're on 77, or at least we're on the on-ramp. So we're on 77. Okay, and so we get on 77 and it's 5 miles. Now, I didn't measure these, I just made up the numbers, okay? So your solution may not be too accurate. I don't think it's nowhere near 5 miles up there. Maybe 2 if it's that far. I don't know. I've never measured it, but anyhow, so from 77 to Portage, you know, from, what was that, Everhard or whatever, I done forgot the road again. But anyhow, we made that left turn and we got on 77. And now I'm saying there's a 70% chance that we can drive 65 mile an hour. And a 20% chance that we're going to, you know, traffic's going to be bad and we're going to do 40 mile an hour. And a 10% chance that we can get out and walk faster. Okay. which if you've ever been on 77, you know that can happen once in a while, but very rarely. Okay, but if they're doing a lot of construction, you know, things like that could happen. So I've got three different possibilities with three different speeds. Okay. So now what we have to do here is we got to come back over to this time of travel, and I give you a speed array. Now this speed array, you know, like I'm giving you three possibilities here: 70%, 20%, or 10%. I could give you 8 possibilities or 2 possibilities, and this function should handle that for you. Okay, so you don't have to worry about how many there are. But what you have to do is you have to build the array. And so you put the percent chance of speed in the first one and then the speed in the second. So what we have to do is, again, put a comment in here so you can keep track of which one you're doing, okay? And so I'm going to build my speed array, which is just the numbers I'm giving you right there. 70, 65 mile an hour. And you can actually just hit enter and put them on a separate line here. And so this is going to be 20 and 40 mile per hour, and 10 and 5 mile per hour. Okay, so these are that's your speed array. And then we simply call this function. Okay, now look at this function. This function is going to calculate the distance. We need to pass it the distance. Okay, so we need to pass the distance, which I gave you was 5 miles. Again, I told you I didn't measure it, I'm just made it up, but that's 5 miles. That's the distance we have to travel. And this is our speed array, which are the chances that we're going to go these various different speeds. All right, so we stick this in here, and what it's going to return to us is how long it's going to take. If we're driving, it's going to return to this. So let's say that we can go 65 miles an hour for 5 miles. All right, and I think I calculated that in the slides. I forget how long it was, but you know, it's, what's that? Call it 4 minutes or something. But this is returning it in seconds. Okay, so I'm doing the calculation here, so it's time to drive in seconds. So it's going to tell us how long that is. So the total time, we're going to add to our total time. So we're going to capture that, and so this is going to be the time up 77. This is going to be the time that it takes us to go up 77. So we're going to call time to travel. And the distance we're going to travel is 5 miles. And the speed array we just created right above there, and we're going to pass it that. All right, now this is way more than enough to test this. So I'm just going to run this. And I didn't put a semicolon in there, so we'll come over to our command window here and see I have some kind of error message. Total time undefined. All right, so here, because I didn't define it, I stuck it in the if. I need to take that out of there. All right, so when we run this now, it took 276 seconds. Okay, if I run it again, hello, there it goes. Wow, 3,600 seconds. That's a long time. That's a whole hour. Come on. It's running. I don't know. That 3600 time looked crazy. Okay. Come on. It's flipping me to the figure. Okay, so when we run this, okay, I guess the one thing, let's see, I just want to double check that percent chance of speed. I just want to test this time to travel. So 360. What was my speed array? All right, so there's a 10% chance we could do 5 mile an hour. Yeah, oh yeah, 10% chance we can do 5 mile an hour, and I told you it was 5 miles, so it will take me an hour, right? That's why that every once in a while it takes an entire hour to go that 5 miles because we're doing 5 mile an hour. All right, I was a little worried about my function, wondering if I messed something up. I thought they worked, but yeah. So that's why every once in a while you get this oddball way out of, it's going to take us an hour to get up to Portage, but that could happen. I've seen it like that. I remember years ago we had this one guy, he was sent up to Akron, and he left, and they called like a couple hours later, and they said, well, where are you at? Where's Jeff at? The guy's name was Jeff. It's like, where's Jeff at? And we're like, well, I don't know. He left 2 hours ago. And he showed up a couple hours later. He says, yeah, I've been sitting on 77 all afternoon. Never got anywhere. He never got to Akron. So
I've had that happen.
What's that, Patrick?
I've had that happen. It was my first time
Yeah,
going
exactly.
to an RPC meeting for work. I was by myself, and I was stuck there for 2 hours and missed the whole meeting.
Yeah, it happens occasionally. So that's why every once in a while I was running this, and it was coming up with 3,600. That's this 10% chance. Okay. So that's why I was saying 3,600, which was a whole hour. Okay, so that it was just all right. So, but anyhow, so we calculate that, and now we can add this time. So we can say the total time is the time up 77 plus the total time. Okay, and I forget if MATLAB supports this. Let me run this way and see if I can error. Okay, I have yet to see it give us the extra 10 seconds from up here though. But so anyhow, so you can use this plus notation here, and instead of saying like total time is equal to total time plus, this does that for you. certain programming languages will allow you to do that, but if you want to, you can spell it out. Like that. All right. So, but then, all right. So now we're sitting at the light. Okay. So the next problem is here. We're sitting at the light at Portage trying to make a left turn. And the chances is, how long do we have to sit there? Okay. So lights, are timed, and it depends on the intersection how long the cycle is. Usually they're about a minute and a half up to 3 minutes long, depending on how complex the intersection is and stuff. So this is kind of a simpler light here. What I'm saying is it's 180-second light, and it's green 50% of the time, which means it's red the other 50% of the time. We'll ignore the yellow. Nobody drives through yellow lights, right? So it's just a red or a green light here. All right. And so now we're going to use our other function, which is traffic light. All right. And so this function here takes the total cycle time and the chance that it's going to be green for you. Okay. So, but assuming the direction you're coming. All right. And so what that means is, like, if you hit the light and it's green, then you don't have to stop at the light, right? You can just go ahead and make your left turn and continue on. But if it's red, then you're going to have to wait. However, the next question though is, has it just turned red? Don't you hate it when you get there and it just turns red, but you just couldn't go through? All right, now you got to sit and wait for the entire red light. But that doesn't happen all the time. A lot of times you get there and it's already been red, so you may only have to wait 5 seconds instead of 60 seconds or however long it's going to take for it to change, because by the time you got there, it only had a few more seconds to go. So that's what this function calculates, the random possibilities of the light. So now we call this, and it gives us how long we're going to have to wait at the light. Okay. And so we come back to our program here. So now we're at the light. Time to wait at the Portage. Well, I'll just call it off ramp maybe. Time to wait at off ramp. Okay. And so the total time is 180 seconds. And now I gave you a percentage here. You have to do the math, right? So if it's 180, half of that's going to be 90 seconds. Okay. So it's going to be green for 90 seconds. It's going to be red for 90 seconds, what I'm telling you here. So that gives you your time to wait. And then we're going to add that. So we're going to come in there and add that then to our total time. And so we can run that. And I haven't put semicolons in here at the moment. You definitely want to do that, but well, that don't make sense. Why is my total time going to 0? Total time. Maybe that plus isn't working. There we go. Come on. All right, so see, there you see the difference, right? See, this first one was a time up 77. And then here we had to wait an extra second, a little over a second for the light to turn. All right, now here we made it through the light. We didn't have to wait for the light to turn. Here we had to wait a long time for the light to turn. So you see what it's doing? It's just adding these together. So then what we're going to do is we're going to do the next one. I'm not going to do them all here. I'll do, we're going to drive a half a mile to the next light. Okay. So we're going to drive half a mile to the next light. Okay. And there's a 90% chance that we're going to be doing about 20 miles per hour because there's a slow poke ahead of us. And honestly, because the, you know, we're making a left turn and we're only driving a short distance, we're not going to hit the full speed of 45 mile an hour unless we slam on the gas and go. And, you know, that's not safe driving. So, all right. So now we're going to have, time to second light. All right, now I think I labeled these lights. I guess I didn't label the lights here. I did them on the other map. But, you know, if you wanted to, you could label these. You could, like, label and say this is light A, and this is light B, and this is light C, or something, and label them that way. But anyhow, so the distance we're going to travel is half a mile, and we have to build our speed array. And our speed array was 90% chance of 20 mile an hour. And that leaves 10% to go 45 mile an hour. Should have a comma up here. You don't need commas, but my OCD says we need to be consistent. And it's just a little safer to have the comma. All right, so that's going to be the time to the second light, and then we're going to add to that, we're going to add this value to our next one. So I'm going to run this. So now I have 3 times. So see, this is the time it took to go up 77. This is the time I had to wait at the light plus this, which means I didn't have to wait at the light at all. I made it through it. It was green light. And then this is the time it took me to go, you know, up 77 and then to the second light. So now I'm sitting at the second light. And if we run it again, you know, we get different values because it's random. That's kind of the whole thing. All right, so now if we go back then to our program, right, we run this and we'll get the total time. Now, the only problem with this is when we run this, we just get one possibility. All right, so now we have to do this for the rest of the way to the college. All right, so you got to do the rest of the lights and the rest of the distances. But now, what we need to do is we need to do this a whole bunch. Okay, so what I'm going to do here is create a vector. So I need to create a vector, and I'm going to run this all through a for loop so that we're going to do it multiple times. So what we're going to do is I'm going to have time of try or maybe calculations, of calculations is equal to nothing. Okay. And then now notice this is just a null. I just initialized this. Now I'm going to create a for loop, and I'm just going to do this, say, for 100 attempts. Okay, so for 100 attempts, I'm going to run through this, and at the end of it now, after I've calculated my total time, I'm going to store that into this vector. So the total time, this is the total time for one calculation, but I'm going to add it to all my previous calculations. So I'm going to end up with 100 of these. Okay, and then I'm going to end my for loop. And then now I can plot these things. I think there's, I think I used the bar to plot. I don't remember. But we're just going to plot these possibilities. No, what is it? Calculations. Okay, and then we should like get the average. And then turn my hold on. Hate that autocomplete. Okay. And then plot the average time. Let's see. I'm just doing this really quick here because I need to. All right, so invalid constant left-hand side. Okay. Yeah, my for loop, I forgot. I need to have for loop equal to something. I'll use my K in there. All right, and so here now is, I don't see the average. It looks like it didn't plot the average, but here are all the random values. And then I need to plot the average. I'm not sure why that did not plot there. Maybe it did plot and it's just a color. No, I'm not seeing it plot there. Okay, so not sure why it's not plotting the average at the moment here, but Okay, now, I guess, yeah, the other thing I forgot was we want to plot minutes, not seconds. So remember, this calculation was average time. Well, they were these were calculations in seconds. I think I actually asked you to do it in minutes. So if that's the case, you need to divide by 60. Not that it's just going to change the scaling a little bit, but let's see. Let's see if that looks any better. There it is. It's there. Actually, yellow's too light. Okay. Maybe it was there before and I just didn't see it. But all right. So here's your plot. Okay. So there's the plot. The blue line is the average value, and again, this was in minutes right now. So I plotted this one in minutes here. Okay. But so once you go through and you do all your times, how long it's going to take to do your travel from light to light to light until you get there, and then how long you're going to have to sit there and wait at the lights, and you add all those times up, and then you can plot them. Right, you plot them, but you calculate the average of them, and that's going to give you an estimate of how long it's actually going to take you to get there. So, on an average day, it should take you, this was 10 minutes here. So it looks like maybe about 12, 13 minutes to go from the mall to Stark State. Okay. That's the average. Now, actually, that average is kind of skewed because there's so many of these that are taking a whole hour to get up 77. Okay. So that 10% number I gave you for the 77 is probably a little overkill. It's probably more like, 2% or something. But that's why the time seems kind of high. All right. But that's what you guys need to do. You just do it for every stoplight and every section of the map. Right. So as you're going from one light, oops. As you're going from one light here to the next light, you have to calculate these distances. How long is it going to take you to travel each distance? And then how long are you going to have to wait at each one of the lights? And add them all up. You add them all up. Just do a plot using the bar function instead of the plot function. And then turn hold on, calculate the average, and plot the average line. And answer the questions and the homework. But that's pretty much all you have to do.
Okay, that makes a lot more sense now.
All right.
Yeah,
So
definitely
I
a
did
lot clearer.
record this. What's that, Hannah?
It's definitely a lot clearer.
Okay. So I did record this, so I'll try to remember to post it out there so everybody can see it. All right. So, but yeah, this was pretty good. I'd been meaning to try to do this, so I'll just post this recording so everybody can see it.
Alrighty.
Okay,
Sounds good.
So, but, all right, I gotta go. I got another student coming on at 9 for a different class. So
Thank you
Alrighty.
very
Thanks for
much.
helping us.
you're welcome. Have fun.
Will do.
Will do.
Bye.
Of
This is supposed to be fun, right? Not work.
course.
I'm gonna rename it Home Fun instead of Home Work. How's that?
Perfect.
All right. See you guys.
See ya.